Good
Good
morning,
morning.
everyone, and welcome to the lecture. This is lecture number 11 in potential energy, and we are dealing with the potential energy curve. In the last class, we had seen this potential energy curve, and we had seen what happens at different points. We have seen what happens at point C, D. We have seen what happens at point B and E. Do we remember this? Yes or no? This is known as the potential energy curve. Every conservative force is associated with a potential energy, and this force is negative of the slope of this potential energy. I hope we understand this. Yes or no? Okay. Then we were discussing this graph. On the top, there was graph of potential energy versus distance, and then on the bottom, we had the graph of potential energy force versus the distance, and this graph tells us how potential energy and how force relate to each other. Do we see this graph, yes or no? Now, have you seen this, have you drawn this graph? Now, what are the important points that you see? If I call this point as A, if I call this point as, if I call these points A, B, and C. These are the corresponding points A, B, and C. What do you see here? At these points A, B, and C, at all the 3 points, force is zero. Yes or no? Do you understand these? At the 3 points, this force is zero at point A, at point B, and at point C. Forces are zero. Why it is zero? Because at point A, point B, and point C, important points. At point A, B, and C, the slope of the graph du by dx is zero. That implies the force is zero. You can see this, yes or no? Okay. Now, there's one more thing you have to understand. And the thing that you need to understand is when is the force attractive and when is the force repulsive. Now, attractive force is negative. I mean, in this diagram, the force, if the force is coming as positive, that force will be treated as repulsive. If the force is coming as negative, that force will be treated as attractive. Now, when is the force repulsive and when is the force attractive? Can anyone make me understand that? When is the force repulsive and when is the force attractive? In this region, the green region, this is the green region here. You can see the force is repulsive. Why is the force repulsive? Can anyone explain this? How you can explain this? Let me name the points differently so that let me name the points differently. Yes, can anyone? Let me name this point as A, let me name this point as B, this point as C, and this point as D, so that it is according to the diagram that I have drawn. A, B, C, and D. So in this, it will become at points B, C, and D. Yes, when is the force attractive or when is the force repulsive? As I can see, no one understands this, so there is no point of wasting any more time. On x increasing, when x increases, if the potential energy decreases, that implies that the slope du by dx is negative and force is negative of the slope, force is positive. When I mean positive force, that force is repulsive. The region in the graph where we see this, what is the reason? In which region of the graph do we see x increasing, u decreasing? In which region of the graph do you see that? I hope you can understand that one at least from the graph. In which region of the graph do we see on increasing the value of x, u is decreasing? I told you many times, many months ago about the increasing, about the slope of a graph. I, I don't think you remember it as expected, but can anyone tell me in which region of the graph do we see x increasing and u decreasing? The slope of the graph is negative. In which region do we see this? Do we see this or not? Where? In which region? Okay, in the region AB, in the region AB, you can see when x increases, u decreases, and therefore in the region, green region, in the green region, in the green region, in the green region, the force is repulsive. There is one more region, this region AB. In the region AB, force is repulsive. There is one more region in which the force is repulsive. Can you tell me what is the other region? Yes?
C to D, sir.
C to D is another region where the force is repulsive because on increasing the value of u, the value of on increasing value of x, the value of u decreases. Slope is negative. So AB and CD are the region where the force is repulsive. Let us now think about this pink region. What is happening in this pink region?
X increasing, U increasing, sir.
In this pink region, if on increasing the value of x, if u also increases, that implies that the slope of the graph is positive and f is negative of the slope. That means f is negative. In that region, the force is attractive. The force is attractive. This is represented by the region BC of the graph. In the region BC, we see this thing happening, and that is where the force is attractive. I'll give you 2 minutes to note this down. I hope everyone has understood this. Then we move ahead. We had seen in the previous class also that the points that we see here, B, C, D, and E, they are different from each other. They are not exactly similar of each other. We had seen that they are slightly different. What is the difference? I told you the difference also. What is the difference? Between between B, C, D, and E, what is the difference? Between B, C, D, and E, what is the difference? We have seen the difference. No one remembers it. Okay. The next heading is types of equilibrium. Types of equilibrium. And the first type of equilibrium is known as stable equilibrium. The first type of equilibrium is known as stable equilibrium. Now, what are the important points that you have to remember about stable equilibrium? Anyone knows this? Stable equilibrium.
Maximum stability, sir.
This is the point which has got maximum stability. Anything else?
Potential energy is minimum.
Potential energy is minimum. What else?
Force is zero, sir.
Force is zero. That implies du by dx is zero. Potential energy is minimum. That also implies du by dx is zero. Both mean the same thing. Du by dx is zero. Now, basically, this becomes the minima of the function, and to find out the minima of the function, you can find out the second derivative of that function. Do you know this? Maxima, minima? Second derivative of the function, and the second derivative of the function should be greater than 0. That becomes the condition of stable equilibrium. Do we understand this? Do we remember this? Then the second type of equilibrium is known as what?
Stable equilibrium.
Unstable equilibrium. Unstable equilibrium. For the stable equilibrium, you can also, since you have space here, you can also draw a graph. You can also see an example. If the body is like that in a valley, potential energy is minimum, and this is the condition of stable equilibrium. Now, what happens in unstable equilibrium? What happens in unstable equilibrium?
Potential energy is maximum, sir.
This is the condition of minimum stability. Potential energy is maximum. But even if potential energy is maximum, your du by dx is equal to 0. It is the condition of
Force
equilibrium.
is zero.
Force is 0. That also implies that du by dx is 0. Now, this is the condition of maxima. So, here your second derivative will be less than 0. Do we remember this? Do we understand this? Yes or no? No, yes. So this is an example of unstable equilibrium, something at the top, if it is kept. As long as it is at the top, nothing happens. If I just push it, it will just go down. There is also a third type of equilibrium. What is that third type of equilibrium? The third type of equilibrium is known as neutral equilibrium. The third type of equilibrium is known as neutral equilibrium. Here what happens? What happens? Here potential energy is minimum. Potential energy is maximum. Here potential energy remains same. At every place, the potential energy remains same level. Not maximum, not minimum. It remains the same level, but the slope is always equal to 0. The force is 0. That also means that the slope is 0. And here your du d2u by dx square becomes equal to 0. So this becomes a case where the body is on a flat surface. There is no force acting on the body even if I move it left or right. There is no force acting on the body. The restoring force acting on the body is 0 no matter where I move it. So this becomes an example of neutral equilibrium. Do we understand this, or this is gone above our head saying bye bye? Three types of equilibrium. Three types of equilibrium explained in the most beautiful way. I'll give you 2 minutes to note this down. Anyone has understood this? Okay, I'll give you 2 minutes to note it down. Okay, then we have this question coming up. There are different cases given. You have to tell me which case is a case of equilibrium and what type of equilibrium is this. And if there is not an equilibrium, you have to tell me which one is not the equilibrium. Case number 1, A. Is it an equilibrium? Yes or no?
Yes, sir.
What type of equilibrium?
Neutral equilibrium.
Neutral equilibrium. Case number B.
Stable equilibrium, sir.
Stable equilibrium. Good. Case number C.
Unstable.
Good. We have understood this. Case number D.
Stable, sir.
If I push it, it will come back. So stable equilibrium. Good. Case number E.
Neutral, sir.
Neutral, sir.
Good. Case number F. This case is not in equilibrium because the moon is moving around the earth. It is always experiencing a centripetal force. So this is not in equilibrium because it is accelerated. Do we understand this? So this is not the case of equilibrium. Everyone understand this, or this has gone above our head saying bye bye? Huh? Okay. Can you move on to the next question? Huh? Question number 2. This one. Find out the position of equilibrium and determine whether they are stable, unstable, or neutral. Which are the points of equilibrium? This is, remember, force displacement graph. Force displacement graph, not UX graph. So now you have to understand which is stable. This is force X graph.
B to D stable, sir.
B to D, completely stable. What are the points of stable? What are the points of unstable? And what are the points of neutral equilibrium? If the graph would have been given between U and X, this is the graph between U and X, but this is a different question. This is the graph between U and X. In this graph, this is a graph between U and X. In this graph, what are the points of stable, unstable, and neutral equilibrium? Yes. In this graph, what are the points of stable, unstable, and neutral equilibrium?
At point C, stable, sir.
Point C is stable, then
Point E, unstable.
this is unstable, then between F to G,
Neutral, sir.
it is neutral. This is between U and X. The question that we are asking is between f and x, not u and x. Anyone understand this one? Anyone
Sir.
understand this one? But the question is here, this one. Between f and x. I will give you 2 minutes to think about it. Okay, so how are we supposed to do this? I look at point B. B, D, and F. These are the points where we have 4, 0. So B, D, and F are the points of equilibrium. Now I will have to find out what type of equilibrium exists at B or D or F. F is very simple. After F, there is no force. So F is the point of neutral equilibrium. We all understand this because force remains 0 everywhere. So F is the point of stable neutral equilibrium. That's not a problem. The only problem is between B and D. One is a point of stable equilibrium. The other one is a point of unstable equilibrium. How to find out which one is what? Now you look at point B. At point B, if the particle is there, it remains at rest. Nothing happens. But if I increase the distance from B, if the particle goes away from B, the force on the particle is negative. That means the particle will try to come back. If I decrease the distance from B, so if it goes on this side of B, so it is going away from B on this side, the force would be trying to pull it back. The particle goes like this, the force is in the positive direction. When the particle goes in the positive direction, force is in the negative direction. When the particle goes in the negative direction, force is in the positive direction. So B is the point of stable equilibrium. Do we understand this? So B is the point of stable equilibrium. Now you look at the point D. What happens at the point D? If the distance increases, it goes away from point D. Force is also acting in the same direction. Force is also in the positive direction. So if it goes from D in the positive direction, force is also pushing it in the positive direction. It is never going to come back. And therefore, this point D is the point of unstable equilibrium. Do we understand this? Do we understand this? Yes or no? Boys?
Yes, sir. Yes, sir.
This is how we find out the points of stable, unstable, and neutral equilibrium, my dear friends, applying some common sense, applying some logic, and I'll give you 2 minutes, 2 minutes, and 2 minutes only to note this down, and then we would be back to business. 2 minutes you have to show your talents. Well, then let's move ahead with this question. Question number 4. It's a simple question. Tell me the answer. The potential energy of a body is given by A minus bx square. X is the displacement. The magnitude of force acting on the particle is how much? Constant, proportional to x square, inversely proportional to x. And the answer is do we have an answer, my dear friends?
B, sir.
It is proportional to x. How do you get it? It is very simple. Force is minus du by dx. So you just have to find out the negative derivative of that. So minus of d by dx of a minus bx square, and you will get it as plus 2bx. B is a constant, so it is directly proportional to x, and that is the answer that we are looking at. Yes or no? No or yes? Everyone got this? Huh? This is the next question. Question number 5. A particle moves in a potential region where U is given by this formula. Where will the state of equilibrium come? You need to also tell me if that state of equilibrium is sorry, stable, neutral, or unstable. I'll give you 2 minutes. Yes, the answer is B. What type of equilibrium is this? Stable, unstable, or neutral? What type of equilibrium is this? Stable, unstable, or neutral?
Stable, sir.
Why stable, sir? Okay, let me try to find out. For equilibrium, the first thing that must be applicable is du by dx is 0. Yes or no? So I differentiate this. What is the derivative of this? 16x minus 4 will be equal to 0. From here I can find out x as 4 by 16, and that is the first answer. You will get x as 1 by 4. So at 1 by 4 you have an equilibrium condition. Now you have to find out whether the equilibrium is stable or not. How will I find out whether the equilibrium is stable or not? How will I find out whether the equilibrium is stable or not? Yes. I will find out second derivative of energy. I will find out the second derivative of energy. And what is the second derivative of energy? I have to find out the derivative of this part. What is the derivative of this part? That was the first derivative. I have to find out the derivative of this part. What is the derivative of this part?
16, sir.
And this is greater than 0. Therefore, this equilibrium that we are getting has to be stable. Do we understand this? So this is the case of an stable equilibrium. To find out whether the equilibrium is stable or not, what we do is we just take the second derivative, put the value of x in that second derivative, and find out if it is coming as positive or if it is coming as negative. This is a very famous question that has come in JEE many times, so it's a simple one. The potential energy between two atoms in a molecule is given by this equation, where A and B are positive constants and x is the distance between the atoms. It is given that the system is in stable equilibrium. When is the system in stable equilibrium? I'll give you 2 minutes to get me the answer. Yes, option C is the correct option. And how do you get it? As you know, there is nothing that you have to do for finding out the condition of equilibrium. You have to just find out the derivative and equate it to 0. So you have to find out the derivative of d by dx of complete derivative of a by x raised to the power 12 minus b by x raised to the power of 6. What is the derivative of this? Minus 12 into a divided by x cube minus of minus 6 into b divided by x raised to the power 7. This has to be equated to 0. How do you do that? I think after that it is simple. So you will get x raised to the power 6 as 2a by b, or your x becomes 2a by b raised to the power of 1 by 6, and that is the answer, option C, and that is correct. Do we understand this, everyone? Okay, well done. If you could do this, it's a good thing. I'll give you one more. If you can do this, that means you have understood everything that you had to understand about this particular topic. The problem is not with your understanding, the problem is with your remembering. That is one thing that you need to work on. The potential energy of a system is given by the first figure. The force acting on the system will be represented by which graph? Question number 6. Yes, my dear friends. Which graph? Which graph is the force represented by? And the answer is option C. When x increases and u increases, and here when x is increasing, u is also increasing, like this. Slope is positive, so force is negative. The slope is constant, so force is constant. Force should be constant and force should be negative. It is only there in this graph. After this, there is no force, there is no energy, there is no force, everything is 0. So the answer is option number 3. Do we understand this? Remember, when slope of u and x graph is positive, force is negative. Remember that, and if you find more questions, I don't think you will find any more of these. We are done with this topic. In the next class, we will go ahead and hopefully in a couple of classes, we should be able to wind up your work, power, and energy. I hope everyone has enjoyed this class and understood this. Take care. God bless you. I'll see you in the next class. Bye bye, everyone.
Thank you, sir.